So
And
we'll
sir, did you
begin.
check?
Yes.
Did you check my pressure one that I sent you that day?
You submitted the pressure, but that was not complete. Then you
Yeah, but then
resend
I
on
sent on your
WhatsApp.
new number. Basically, I completed it. I sent you on your new number, the full version. I don't know what happened, but I completed the
Okay.
before I completed
Okay.
it. So I just want to
Okay. I
know,
will
can you
see.
mark it?
I will mark and then share with you.
Okay, sir.
This was a pop quiz 11, the MCQs pop quiz 11. If you have any doubt, you can ask your doubts. Question number one. If you don't have a doubt, I'll just let you know the answer. Question number one, the correct answer is A. Impulse is a change in the momentum. And likely next week, we will have another group starting, which is starting from topic one. Those who are interested to join that group, let me know. So I will switch them to the other group. And those who want to stay in both groups, that is also fine. You can just let me know either you want to switch or you want to stay in the old group or you want to have access in both groups. Because if you have an access in both groups, then you have to do the pop quiz for both groups as well as the weekly homeworks. Question two, any doubt? Any doubt in question two?
No, sir.
The correct answer for this one is C. Question three, any doubt? Any doubt? Question three.
No, sir.
Okay, doubt in question three for one student. I'll explain that. In question three, uh, the question is a constant force act on a body. So there's a force, constant force, which is acting on the body, causes the momentum of a body to increase. Like there's a change in momentum or increase in the momentum. Which expression relate the force to the momentum and the time taken? We know the change in the momentum or impulse, because the impulse is also called the change in momentum. What is the impulse? Impulse is a product of force and time. So if you need the force, so it will be impulse divided by time. So when impulse is divided by time, we call that as a force. And what is the impulse? Impulse is a change in the momentum. So when change in momentum divided by time, we will get a quantity, and that quantity is refers to force. Is it clear? So for those who just joined now, the correct answer for question number one, it was A, and question two was C. And question three is A again. Question four. Any doubt in question four?
No, sir.
No doubt in question four?
Yes, sir, I do have a doubt on the question.
Question four?
Yes, sir.
Okay. Look, in this question, we need an impulse. What is the formula for impulse? There are two ways you can calculate the impulse. Impulse is a product of force in time. That is one formula. And there's also another formula for impulse. It's the final momentum minus the initial momentum. When you take the difference of the two momentum, we call that as impulse or the change in momentum. Yes, Anas, I just said the answer. The question number one, the answer was A. Question two, the answer is C. And question three, the answer is A. So in this case, the direction has changed. So when the direction changed, how to work out the impulse? In that case, it will be final plus initial, like you add them. Or even if you use the formula that its impulse is a difference between the final and the initial, momentums. So if the direction change, we add the two momentum to get the impulse. Yes, because the direction has changed, it bounce back. So when direction has changed, how we calculate an impulse? It will be the sum of final momentum and initial momentum. What is the final momentum? The speed is 1 and the mass is 2. So the momentum will be 2 kilogram meter per second. And what about the momentum here? The speed is 3 and the mass is 2. So 3 multiplied by 2, 6 kilogram meter per second. So what will the impulse when the direction changes? So it will be 2 plus 6. So 2 plus 6, what we'll get? We'll get 8 Newton second. So the impulse or the change in momentum here is 8 Newton second. So D will be the right answer. So if the direction changes, you add the two, you add the final and the initial to get the impulse. If the direction does not change, then you subtract the final and initial to get an impulse. Is it clear?
Yes, sir.
So remember the formula for the impulse, that when the object hit and bounce back, if you want to get the impulse will be final plus initial. And if the direction does not change, the object continue to move in the same direction and you need an impulse, then it will be final minus initial. So in this example, because the direction has changed, it bounced back. So momentum, it will be 2 multiplied by 3, which is 6. Momentum here, 2 multiplied by 1, which is 2. Because the direction has changed, so how to get an impulse? Final plus initial, so 2 plus 6. What will the impulse? The impulse will be 8 Newton second. Question 5, any doubt? Question 5.
No, sir.
No doubt in this? So question number 5, the correct answer is A. So explanation for this question, as you can see, an object is there moving at a speed of 3 meters per second. So there's an object and it's moving at what speed? It is moving at a speed of 3 meters per second. Then after the time, the object move at a speed of -4. What does -4 represent? -4 represent that the object has changed the direction or it is moving in opposite direction. So the mass of an object is 5 kg. This object is 5 kg and it's the same object, so 5 kg. First, as you can see, the direction has changed. If a direction has changed, how I'll get an impulse?
Final plus
Yeah.
initial.
So impulse, the normal formula for impulse is final minus initial, okay? This is the normal formula when we want to calculate the impulse of an object. If the negative sign was not given and we want to calculate an impulse, if they only said that the direction has changed, then we'll use a formula that it will be final plus initial in that case. But now they did not mention that the direction has changed, but we worked out that the direction has changed because this is given negative and this is given positive. So if the value of the speed is given negative, so we will use the first formula for impulse. Impulse is final minus initial. So what is the final momentum? How we work out the final momentum? This is minus 4 multiplied by 5. So this is equals to negative 20. The momentum. And what is the momentum here? 5 multiplied by 3 makes 15. How to get an impulse? Impulse is the difference in the momentum, the final minus initial. So what is the final? The final is minus 20, the momentum. Minus, what about the initial momentum? It is 15. So when it is minus 20, minus 15, so what we'll get? We'll get minus 35 Newton second or kilogram meter per second. So if it was not given a negative sign, in that case, if the same question was there, if this was the same question and instead of the wordings, the figure was given to you like this. That there's an object moving at a speed of, there's a 5 kilogram object moving at a speed of 3 meters per second and it bounced back with a speed of 4 meters per second. And the question was calculate an impulse. So in that case, when they show us that the direction has changed, so what formula we use? We use a formula that the impulse is final plus initial. Final momentum plus initial. So final momentum is 20, initial momentum is 15. So final plus initial 20 plus 15. So what we'll get? We'll get 35 in that case. But right now, in this question, they give us the sign that they give one of the velocities a positive and the other velocities a negative. So when the velocities with the signs are given, then what formula we should use? We should use a formula that the impulse is equals to final minus initial. So the final will be 4 multiplied by minus 4, like minus 4 multiplied by 5, which is minus 20, minus initial is 5 multiplied by 3 makes 15. So 20 minus 20 minus 15. So that is equals to minus 35 newtons second. Is it clear?
Sir,
Yes.
when they give us the signs, when they give us the values and signs, we use the formula final minus initial.
Right. When they give us the
Always.
values and the sign, final minus initial. But when they don't, they only give us the, like the figure is shown that the direction has changed. So in that case, you will directly use final plus initial to get an impulse.
Yes, I have a question, sir. Final
Yes.
plus initial, it will be minus 20 plus 15, right?
So it will be 35 in that case.
But it's minus 20 plus 15, sir. Shouldn't be like.
Look, when you work out here, 5 multiplied by minus 4, that is minus 20, okay? Minus, because the formula which we use, if the signs are given, impulse is final minus initial. So the final is minus 20. This is a negative sign of the formula and the initial is 15. So we put 15. Minus 20 minus 15 is what? It is minus 35. That is why we are getting A as an answer.
The direction was changed. Yes, sir.
Direction was changed, but in the question they did not specify. They only give us a sign. So when the signs are given, in that case, you will use a formula impulse is final minus initial. But when they give us, they only show us by a figure that the object bounced back. In that case, if we need an impulse, it will be final plus initial.
Clear, sir.
So if the value of the speed with the sign is given, final minus initial. But if the value of the speed is given with proper show in direction, because we don't know whether plus 3 is the right direction and minus 4 is a left direction, or whether plus 3 is the left direction and minus 4 is the right direction. So it is important that according to the question, you use a formula. Is it clear?
Yes, sir.
Then we have question 6. Any doubt in question 6? The question was, which object has a momentum that is identical? Because momentum is a vector quantity, so identical momentum means it should be in the same direction as well. So if this is moving towards right, the other should also be towards the right. So which is toward the right hand side? C is also towards the right hand. C is also towards the right hand side. And it has the same magnitude, same value will be there. Question 7, any doubt? How to do question 7? As you can see, here the direction is given. How to get an impulse? How I should get impulse? Add or subtract?
Adding.
Add. So when I get an impulse, impulse will be final plus initial momentums. What about the mass is 0.5. This is 0.5 kg. This also 0.5. So 10 multiplied by 0.5. So that is equals to 5. This is equals to 5. And 8 multiplied by 0.5, it's equals to 4. So it is final plus initial. So 4 plus 5. So what we'll get? We'll get 9. That's an impulse. But the question was the force. How we can work out the force? We have the formula that impulse is force multiplied by time. So impulse is 9. The force we don't know. And the time interval is also 0.5. So this is 0.5 is multiplied. Other side will be divided. So 9 divided by 0.5, that is equals to 18. So the impulse is equals, or the force is equals to 18 Newton. And which direction the force must act? As you can see, the object is going upward. So which direction the force should act? So the force should also act upward because the object has changed the direction and moving upward. So the force should also act upward. Otherwise, if the force is acting downward, the object will also move downward. Is it clear? Question 7.
Yes, sir.
Yes, I will repeat. Look, if you need the force, the formula is force is impulse divided by time. How to get an impulse for an object which bounce back? How to get an impulse for an object which bounce back? So here the momentum, the mass is 0.5. So the momentum is 5 because 10 multiplied by 0.5, 5. Here the mass is 0.5 and the speed is 8. So 0.5 multiplied by 8, that's equals to 4. If we need the object bounce back, so how to get an impulse if an object bounce back? So it is final plus initial. The final is 4, initial is 5. So 4 plus 5 makes 9. So we have an impulse of a 9. But we need the force, so it will be 9 divided by time interval is 0.5. So 9 divided by 0.5 will get 18 Newton. So 18 Newton, it can be C or D. But which direction once the object hits the surface, which direction it move? It move upward. So it means that the force should act upward. Otherwise, if the force is acting downward, the object won't be able to move upward. So when the object hit the surface exert an upward force that is causing an acceleration or a change in speed or in direction as well. So correct answer for this one is C. Question 8, any doubt? Question 8. What is the unit of change in momentum? Impulse, so that is C, Newton second. Question 9. Which expression for the momentum of an object is correct? Momentum is the product of mass and velocity. So it's also C is the right answer. This is what force multiplied by acceleration. Can anyone tell what is force times acceleration? Which physical quantity we'll get? If the force of an object multiplied by acceleration.
Teacher, you got force.
Sorry, mass multiplied by acceleration. So it is force.
Resultant force.
Yeah, resultant force. Mass gravitational strength. What we'll get?
Gravitational potential
Weight.
energy.
Weight.
Oh, wait.
Because mass times the gravity. This is a momentum. Half mass into velocity square. What we'll get?
Kinetic energy.
Good.
Kinetic energy.
So we'll get a kinetic energy from this. As a kinetic energy is half mv square. Question 10. Look, in this question, a moving ball with a momentum of 25 collide and it rebound with the same speed. So if it rebound with the same speed, if it was having a momentum of 25, this will also have a momentum of 25. How to get in? If we need the force, so if I need the force is impulse divided by time. How to get an impulse in this case as the object bounce back? Because it mentioned it's rebound. So what I should do, I should add the two momentum. So it will be 25 plus 25. So that is equals to 50. What about the time interval? The time interval is 50 millisecond. If it is a 50 milliseconds, we have to convert into second. So we divide by 1000. So 0.05 will be there. That is the time interval. So 50 divided by 0.05. What's the answer? If 50 is divided by 0.05?
1,000.
So it will be 1000. So D will be the right answer for this. Question 11. Any doubt in question 11? It's the same thing. As you can see, an object is there. It's 25, then it bounces back at 50. And if I need the force, so how to get the force? The force will be equals to impulse divided by time. How to get an impulse for an object which bounces back? So we will add the two momentums. If sometimes they give us the speed, sometimes they directly give us the momentum. So in this case, the speed is given, so momentum is not given. So how to get the momentum? We have to multiply this. The initial momentum, the 0.06. 0.06 times 25, which is equals to
1.5.
1.5. So this is 1.5. What about 40 times 0.06?
2.4.
2.4. So this is 1.5 and 2.4. If you need an impulse, if an object bounces back, how to get an impulse? It will be final plus initial. So it will be 2.4 plus 1.5. That will be 3.9. And divided by time, it's 50 milliseconds. How to convert?
Divide by 1,000.
Divide by 1000. So when we divide by 1000, this will be 0.05 seconds. So it will be 0.05 seconds. So 3.9 divided by 0.05, which is equals to 78 newtons. So that's why D will be the right answer. So it's very important. Like you look for the SI units for the unit conversion, like time should be in second. If it's given in minutes or hours, you have to convert into seconds. Question 12. A mass of an object of a mass 50 kilogram changes from 2 meters per second to 10 in the same direction. So if I need an acceleration, what is the impulse?
Final minus initial.
Good. So in this case, the impulse will be final minus initial. And how you worked out that you have to use a final minus initial because the object does not change the direction. So what about the final momentum? The mass is 50 and this is 10, 50 multiplied by 10. So that's equals to 500 minus initial mass is 50 multiplied by 2. So that is equals to 100. So 500 minus 100, that's equals to 400. And the unit will be Newton second. So B will be the right answer for this. Question 13. Any doubt in question 13? The correct answer for this one is C. Question 14. Question 14, whenever the question is related to collision of the objects, remember that you have to use the conservation of the momentum. Like when objects collide with each other, we use the conservation of the momentum. What is the conservation of the momentum? It is stated that the total momentum before is equals to total momentum after. The sphere X collide head on with the second identical sphere Y, which is stationary. So there is a sphere X and it is colliding with identical means like same, thing is same, the mass is also same, each with a mass of 0.15. So this has a mass of 0.15 kilogram, this also has a mass of 0.15 kilogram. This was stationary because I mentioned sphere Y was stationary. So what is the speed of the Y? If it was stationary, so what would be the speed of the Y? So the Y will be 0 meters per second, it's not moving. And the sphere X is traveling at a velocity of 2. So it was traveling at a velocity of 2 meters per second. That is before. And produce an impulse of 0.21 Newton second on sphere Y. Means the change in momentum for a sphere Y is 0.21 seconds. What is the velocity of sphere X after the collision? Now, how to solve such question? So whenever two objects are there colliding with each other, the total momentum before is equals to total momentum after, or impulse of object A is equals to its impulse negative of the impulse of object B. Like the conservation of the momentum according to a law of conservation of the momentum, that the momentum before must be equals to momentum after when the objects collide, or the impulse of one object is equals to negative of the impulse of the second object when the objects are colliding with each other in the absence of any resistive force. This will be the condition. So how we can solve this question? So like example, if I draw the figure again, just to give an idea, this is X and this one is Y. This was not moving, stationary, and this was moving at a speed of 2 meters per second. So if I use the conservation of the momentum, the sum of the momentum before must be equals to sum of the momentum after. Now sum of the momentum before. The mass of an object is 0.15. So this is equals to 0.15 multiplied by and they also give us the impulse. As you can see here, the impulse is equals to 0.21 Newton second. So I can use this formula. It will also give a result, but it will be a long method. If I use the second formula, whenever objects are colliding, they will have because I can solve with this one, but it will be a long method. And for MCQs, we always try to prefer short methods or tricks to solve rather than solving the whole equations. So when objects are colliding, so it means the impulse of X is equals to negative of the impulse of Y. Like they will have the same value of the impulse, but negative. So they mentioned that the change in the momentum is 0.21 Newton second on a sphere Y. So if I use this formula, that the impulse is equals to the final momentum minus the initial momentum. What about the impulse here? What about the impulse? The impulse is given 0.21. They already mentioned that this impulse produce an impulse of 0.21 Newton second on sphere Y. So there's a change in momentum for sphere Y 0.21. What about the mass of the sphere Y? That is 0.15. What about the speed of a sphere Y is unknown. We don't know, we call x. Or you can also say v minus the initial momentum. How to get the initial momentum? They mentioned the sphere Y was initially at rest, stationary. So if the sphere Y was stationary or not moving, so what was the initial momentum of sphere Y? It was 0. Because if something is not moving, its velocity is 0. So this is equals to 0.15 into V and 0.21. 0.15 is multiplied, so other side it will be divided. So 0.21 divided by 0.15. So 0.21 divided by 0.15. What is the answer for this? 0.21 divided.
Sir,
0.2
the answer is 1.4.
1.4. So we'll get the answer as 1.4. But then what about the magnitude? Like what about the direction? If the object is moving in the same direction, then we'll get a positive value. If the object is moving in opposite direction, then we'll get a negative value. Just I'll repeat the explanation for this. See, in question 14, we have a sphere X collide head on with a second identical sphere Y. The mass of each sphere is 0.15 kilogram. The sphere X is traveling at a speed of 2 meters per second before the collision, produce an impulse of 0.21 on sphere Y. What is the velocity of the sphere X? This is what we calculated. This is a velocity we calculated for Y, like this one. When we use this formula, what we did, we got the velocity for Y. If the same thing, we want a velocity for X after the collision. So we use the formula, that the formula for X, when we use, because the impulse of the X will be same as impulse of Y. When two objects are colliding, they will have the same impulse but in opposite direction. So if there was an impulse of 0.21 Newton second, I solved the first part to give an idea that if you need a velocity of Y. Now the main question is calculate the velocity of X. So how you will calculate the velocity of X? The same method you will use, but in this case, impulse of Y was 0.21. What will be the impulse of X? When objects are colliding. So when two objects are colliding, they will have the same impulse but in opposite direction. So if one of the impulse is 0.21, the other will be minus 0.21. So if the impulse of Y was 0.21, what is the impulse of X? The impulse of X will be negative 0.21. So if I solve for X, we have the formula that the impulse for the X will be equals to final minus initial. What about impulse for the X? That is equals to minus 0.21. What about the final momentum of the X? We don't know. Its mass is 0.15. And what about the velocity? We don't know. Then what about the initial momentum of X? How we can work out the initial momentum of X? the X was moving at a speed of 2 meters per second and the mass is 0.15. So 0.15 multiplied by 2, the initial momentum will be 2 into 0.15, which is equals to 0.3. So 0.3 is the initial momentum. Now, this is negative 0.3, other side will be added. So it is 0.21 plus 0.3 because it was negative. So move to other side, become positive into 0.15 into 0.15 V. When you simplify this, so this equals to 0.9 because it's 0.3 minus 0.21, sorry, 0.09. So 0.09 divided by 0.15. What is the answer? 0.09 divided by 0.15. So when you simplify, you got 0.6 meter per second. And because the final answer is positive, so if the final answer is positive, it means the object move in the same direction. So B will be the right answer. So when two objects are colliding, why negative? Because this was an impulse on sphere y. But the question was, we need the velocity of x. So when two objects are colliding, they will have the same impulse, but in opposite direction. If one of the impulse is positive, the other one will be negative. That's why the impulse of the x we took as negative.